Geometry, Chapter 2, Lesson 2. Today we are going to be working on inductive reasoning to make conjectures, and those will be called conditional statements. And then knowing the conditional statement, write the converse, inverse, and contrapositives. So first I have to know what is a conditional statement. A conditional statement is an if-then statement. So if my original sentence was, Mrs. Frickman teaches math, my conditional statement would be, if you're Mrs. Frickman, then you teach math. And the hypothesis is always right after the if. So in this sentence, if you're Mrs. Frickman is my hypothesis. Conclusion is always after the then. Then you teach math. So again, my hypothesis always after the if, and conclusion always after the then. So right here I have a conditional statement. If an animal is a robin, then the animal is a bird. And I have to pick the hypothesis and conclusion. Hypothesis is always after the if. So if an animal is a robin, that would be my hypothesis. Then the animal is a bird. That is my conclusion. Hypothesis always after the if. You should pause the video right now and try to write this sentence into a conditional statement. So an if-then statement. When you are writing this into a sentence, you should look for the two parts that the sentence holds. So in this sentence, I have vertical angles and I have share a vertex. Those are my two parts. Whatever comes first should come after the if. So I could say, if I have vertical angles, I'm going to hyphenate it for VA, then they share a vertex. So the first part of the sentence should always go after the if. Second part is always after the then. Truth value is basically saying if a conditional statement or any statement is either true or false. So I could say the opposite of my original question or statement was, if I'm Mrs. Frickman, then I teach math. That's true. So that would say truth value of truth. Here I wrote, if I teach math, then I'm Mrs. Frickman. Well, there are other math teachers, so this would be big F for false. So the truth value here would be false. You should try to find the truth value in these next two problems by pushing pause, and if the truth value is false, find a counterexample or an example that makes that false. First one, if you live in Honolulu, you live in Hawaii. Now this is saying if you live in New Prague, you live in Minnesota. Well, that's true. So this truth value would be true, so I don't have to find a counterexample. The next one, if a number is divisible by 5, then it's odd. Well, I know 5 times 1 is 5. That is odd. 5 times 2 is 10. That's not odd. So I could say, nope, false, because 5 times 2 is 10, and that's even. So giving a counterexample if any truth value is false. The negation of a statement is the opposite of the statement. So if you ever see this little squiggly, that means not P. That means opposite or not. You should write all 4 of these things down. You will have to come back to this as a reference. So when I check notes, I should definitely see these 4 things written down. So when we talk about these 4 types of statements, you'll often hear me referencing P's and Q's. So a conditional statement, the P is my hypothesis, and the Q is my conclusion. So if you're in room 208, then you are in math class. And I could say, yes, that's a true statement. This has a truth value of true. If you are in math class, then you are in room 208. So the converse of my conditional statement is just switching my P's and Q's. So my Q came first and then my P, but I still write it as an if-then statement. This would be false because there are multiple different math classes. For inverse, it has if not P, then not Q. So I look back at my original conditional statement. It says if you are not in room 208, then you are not in math class. This would also be false because if you're not in room 208, you could still be in math class. My room is 222. And contrapositive is saying if not Q, then not P. When you're dealing with these three statements, you always have to have your first conditional statement to go off of, to base off the sentence. So this is saying if not in math class, then you are not in room 208. I would say that is true, because if you're not in a math class, then there's no way you would be in room 208 for a class, because that is a math room. So we are going to try an example and write out different sentences. So in my conditional statement, the first thing you always want to do is find your P's and Q's. So I'm going to box in my P. If a figure is a rectangle, then it's a parallelogram Q. This would be a true statement. All rectangles are parallelograms. So in my converse, it's putting Q before P. So it would say if a figure is a parallelogram, that's my Q, then it is a rectangle. This has a false truth statement because not all parallelograms are rectangles. Now if I want to work on my inverse, inverse is if not P, then not Q. You should push pause and try writing the statement out yourself. So that would say if a figure is not a rectangle, then it is not a parallelogram. This would also be false. A rhombus is not a rectangle, but it is a parallelogram. And the last one I want you to write out, so pushing pause and trying yourself, is the contrapositive, which is if not Q, then not P. That statement would look like if a figure is not a parallelogram, then it is not a rectangle. And this would be a true statement because all rectangles have to be parallelograms. Here is just a little fun fact. Equivalent statements have the same truth value. So a conditional and contrapositive will always have equivalent statements, meaning they're either both false or both true, or the converse and inverse are either both false or both true. So these two are kind of like pairs, and these two are kind of like pairs. Make sure you fill out the Google form and submit your answers. Have a wonderful day.